All right, statistics. This is Coach Lowe again, going through 6.2 testing paired data with you. There's going to be a lot of stuff in here. I hope I get through. I hope I don't have to do two parts, but I probably will. So let's move it on. Next slide. So here we go. You got three examples here. Decide if the data should be analyzed using unpaired data or using paired data. So unpaired from first semester chapter 5 material, and then paired data is what we're doing now in chapter 6. So explain the reasoning. To see whether college basketball teams in the Big East Conference are attempting more three-point shots, compare each team's numbers, each number of attempts from this season to the number of attempts in this season. So right off the bat, it looks like you're going to be paired data. And it's pretty much because you're going to have two numbers, 2 points of data for each team in the Big East. So because you have 2 points of data for each, that will definitely be paired data. Okay. Next one, to see whether quarterback Tom Brady of the Patriots plays better outside or in a dome. So hang on a second. Playing better outside or in a dome. Investigate his number of passing yards in each context for all of his regular season games in 2009 regular season. So, if that's the case, I'm probably going to lean towards unpaired data because let's think about it. I'm not really sure what kind of numbers we're dealing with. I don't know how many games we played outside. I don't know how many games we played in a dome. So I'm just going to say not necessarily. Oops. Necessarily. That looks awful. Hang on. This is why I'm not going to get through the video. So, not necessarily. It's a little better. You got the same, not necessarily the same number of data points for each game or for Tom Brady. So for the subject, I'm not really sure what we're doing here. So I'm just going to leave it right there. All right, so unpaired. Here we go, third example. To see whether one type of ski wax works better than another, have 10 skiers do a downhill race using one brand of wax and 10 different skiers do a downhill race using other brands. Okay. Right off the bat, I thought this was going to be paired, but I want you to think about this. If it was going to be paired, here's what I would expect to see. I would expect to see 10 skiers, and as an explanatory variable, you're going to swap out the type of wax, and I'll just do wax A, and then I would have the same 10 skiers using wax B, and then I would take those numbers and I would take those numbers and I would have two sets of numbers for each of these skiers. That's what you would see if you were thinking paired data. But what we got is we've got group A skiers, all right, and we also have group B skiers. Okay, and what they're going to do is group A is going to be using a certain wax. I'll just say wax A. Group B is going to be using the other wax. And of course, you're going to get numbers for them, and then you're going to get numbers for them. But because you don't have two numbers for each of these skiers, this is going to be more like unpaired. And again, I am off to the races, just misspelling everything. So this would be more like unpaired. Unpaired. All right. So that's what we really got over here. Okay. Moving on, next screen. All right, let's get to some numbers here. Coors Field, Denver, home of the Colorado Rockies, has a reputation as a hitter's park because of the thin air being at a higher altitude, which supposedly allows the balls to travel farther off the bat. Be great if you're a hitter, probably not so much if you're a pitcher. So to see whether this is going to be true, we're going to compare the home run totals for the Rockies in home games versus road games between the years 1999 and then up to 2008, which is going to be, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 years. All right, so and then for each one of these years, I've got two numbers, right? So this definitely looks like it's going to be paired. So they want us to find the differences in each year. So what I'm going to do is come off here to the side. Sorry if this looks awful. I'm trying to keep this as neat as possible, but we're going to go ahead and find the differences. Now this is actually one of the subtle things different between Unit 5 and Unit 6. So before, when unpaired data, when we're talking about unpaired data, we would actually find the means, like we'd find the means or we'd find the medians and we find the difference in those. So our test statistic was like the difference of means and the difference of medians. Now what you're going to do with paired data is you're actually going to subtract all your points first, then you're going to find the mean. So you're going to find the mean of all these differences. Okay? Let me write that here. You're looking for the mean of the differences. Okay? A little different. So here's what I got. Let's find a different color. All right. So here we go. For the first one, I got 65. Next one, the difference was 63. Next one was 35. 42. 28. 20. 22. Maybe. Now we're getting a lag. 22. Then you're going to get -7. 35. And then 24. Okay. And they want you to graph all of these. So definitely going to be a challenge here. Hang on a second. Let me see if I can make this a little bit more user friendly. If you're going to graph them, let's go with a box plot. And I've sort of already crunched the numbers on that. So here's what I got. When I did the 5-number summary for these numbers, here's what I got. Let's see here. For the minimum, definitely -7 for Q1. Got 22 for the median. Got 31 plus 5, 25. Q3, 42. And then for the max, got 65. So I just plug these in to the scientific calculator, and that's what I got for the 5-number summary. So if I'm down here, let's see here. So let's go -10, 5, 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. And I actually did try to use a ruler to make this even, well, to make it better. And it just was not working with the slate. So here I am going very much caveman style. So got my scale down here. So if I start plotting, let's see here, minimum is going to be -7. You're going to be right in here. Q1 is 22, so you're going to be right about there. We got 31.5, it's going to be up here. We got 42, which is going to go there. Go ahead and connect the box while we're here. And then we got a max 65, so you're going to be right about there. So whisker, and whisker. All right, again, very much caveman style. And tell you what, let's go really crazy here. And I'm gonna go ahead and label. So this would be -7. This is going to be 22. This is 31.5. This is 42. And this is 65. Okay, well, there you go. So that's graphing it. And let's see here, we're just over 10.5 minutes. So let's see what we can do by getting finished. All right, so next screen. Same numbers. Explain how you know that this is paired data. And definitely because each year has 2 points of data. Okay. If we want to know whether they have a greater ability to hit home runs at home than on the road, what hypotheses? Okay. So let's go back to the null and the alternative. For the null, you would be wanting to say something like they have the same true mean, or basically the same ability, no matter where they're at. Okay, that's a Y. And then for the alternative, we'll be looking to see, you'll be looking for evidence to say, evidence being P's got to be less than 0.05. You'd be looking for evidence that they would have a greater true mean, which would also mean a greater ability to hit home runs at home. Yeah, something like that. Calculate and interpret the mean difference. All right, so here we go. Going back to the last screen. Again, I had all my differences up here. And if I add up all the differences, I'm going to use this free symbol. This is sigma. This means sum. So the sum of all my differences was, what did I get? 27? Yeah, so I got 327. And if I'm going to take a mean out of that, that means I want to divide that by the number that I had, which was 10 years. So that means my mean difference would be 32.7. So this is going to be your test statistic. This is your mean difference. Okay, so now moving on to the next screen. 100 trials of the simulation were conducted and the value of the simulated mean differences was recorded to so describe the information provided. Let's see here. You can definitely say something like this dot plot represents 100 simulations. All right, so again, this is what random chance looks like. 1 simulations of these 10 games with a mean difference of 32.7, something like that. So if you're looking at the dot plot, 32.7 looks like you're going to be off this side. So you're going to be over here. So if you're counting dots, that means you're going to have 0 dots going this way. So based on the simulation, estimate, interpret. So here's where you start with sense. So, oh, I'm sorry, that's for the conclusion. Until it's been a long Christmas break. And come on. Come on. Come on. All right, okay. All right. So, assuming, that's how you start this off. Assuming there is the same true mean or the same ability to hit home runs in either venue, whatever, at home or on the road, assuming the same true mean, there is a 0% chance. And looks like I'm